Hey there, fellow science enthusiasts. Today, we're diving into a fascinating topic that might make you rethink the very nature of memory. You see, scientists have uncovered a hidden cost to remembering, and it's not just about the energy surge at the synapse. It's a complex interplay of energy, uncertainty, and the very essence of what it means to be an organism. So, let's embark on this intellectual journey and explore the intricacies of memory and its energy demands. First things first, let's talk about the fundamental concept of memory and its energy cost. Remembering isn't just about storing information, it's an active process that requires energy. Whether it's in a brain, a bacterial network, or a single cell, the act of remembering comes with a price tag. But when is it worth paying for? That's the million-dollar question, and a recent theory paper from the Institute of Industrial Science and RIKEN aims to answer it. Takahiro Tottori and Tetsuya J. Kobayashi built a model organism that tracks something in motion, be it a food patch or a chemical gradient. This organism can't directly perceive the state, it gets a noisy reading and writes it into an internal memory, which also carries its own noise. Now, here's where it gets intriguing. The model charges for two things: how far the estimate deviates from the truth and how hard the organism works to maintain the memory. These two numbers set the terms for the energy available and the cost of memory. The beauty of this model is that it reveals a sudden switch in memory usage. When resources are scarce, the organism ignores memory and reacts solely to current information. But as resources become available, remembering suddenly becomes worthwhile, causing an abrupt shift to a memory-based strategy. There's no gentle ramp-up. Below a certain threshold, the optimal amount to store is zero, and above it, the optimum jumps to a substantial value. This abruptness is what makes the model so captivating. Now, here's where it gets even more fascinating. The model suggests that memory pays off best when the senses are moderately unreliable. If the incoming information is crisp, memory adds nothing new. But if the signal is too noisy, storing it only fills the memory with garbage. There's a sweet spot between these extremes where the past genuinely improves the estimate. This finding aligns with experiments on people, who lean on working memory in the middle range of uncertainty and abandon it at the extremes. But wait, there's more. The model reveals that the energy available, the price of memory, and its internal noise don't act independently. They collapse into one ratio that fixes the boundary between remembering and not remembering. This ratio is the key to understanding why organisms don't always use memory, even when it could improve their decisions. It's all about the resources and environmental uncertainty. Now, let's talk about the limitations of the model. It's intentionally simple, assuming a single changing environmental factor, Gaussian noise, and quadratic costs. Real nervous systems are far from these assumptions. But the point is that even this tidy linear setup produces an abrupt jump, suggesting that the boundary between remembering and not remembering is real. It doesn't establish that any particular cell or animal sits on one side of the boundary, but it does provide a framework for understanding the evolution of costly brains. The study offers a way to think about why memory-hungry computation like the brain arose. It appeared where an organism could afford it and an environment was uncertain enough to reward it. Remembering, or not remembering, is a question evolution has been answering, one energy budget at a time. So, the next time you wonder why you remember certain things and not others, remember that it's all about the energy and the environment. In my opinion, this study raises a deeper question about the trade-off between energy and memory. It makes me wonder if there's a sweet spot for memory in human brains, where we strike a balance between remembering and forgetting. What do you think? Personally, I find it fascinating how memory is not just a passive storage but an active process with its own energy demands. So, the next time you remember something, take a moment to appreciate the energy that went into it. Until next time, keep exploring the wonders of science.